I still don't know why we even need these calculus. It's just a bunch of formulas and graphs.
You'll be surprised. Calculus is actually everywhere. In motion, business, and even in medicine.
Really? That sounds exaggerated.
No, look at this.
Let's start with something simple. A ball. When you drew a ball, calculus explained exactly how it moves. If the height of the ball is represented by the function h of t equals negative 4.9 t squared plus 8t plus 1. That equation describes how high the ball is at every moment as time passes. But calculus does not stop there. When we take its derivatives, h of t equals negative 9.8t plus 8, we get the ball instantaneous velocity, its exact speed and direction at any point in time. That's how we know the maximum height, the time it will stay in the air, and when it will hit the ground.
In business, calculus makes companies make a better decision through marginal costs.
If c of x equals 2x squared plus 4x plus 20, then the derivative c prime of x equals 4x plus 4 shows how cost changes with production.
So, how is calculus connected to business? By using the cost function c of x is equals 2x squared plus 4x plus 20, this function gives the total cost of producing units by finding the derivatives.
Let's differentiate the expression term by term. First, the derivative of 2x squared is 2 times 2x to the power of 2 minus 1, which becomes 4x. Second, the derivative of 4x is 4. Third, the derivative of the constant 20 is 0. So the final derivative is c prime of x equals 4x plus 4.
So, what is the use of derivatives in this situation?
The derivative c prime of x represents the marginal cost, the rate at which the total cost changes when production increases by 1 unit. In simple terms, when x increases a little, the derivative tells us how much additional cost is added. For example, if x equals 10, then c prime of 10 is 4 times 10 plus 4, which is 44. This means producing one more unit at the 10 unit level costs about 44 pesos extra. The term 4x shows that the cost rises faster as production increases, while the constant 4 represents the part of the cost that grows at a steady rate for every extra unit produced. And that's how calculus is applied in business.
Even in medicine, calculus helps the doctor understand how the drugs move through the body.
When a patient takes a drug, the body absorbs and removes it over time. Calculus helps doctors understand exactly how that concentration changes. If the concentration in the bloodstream is modeled as this, the function tells us how much of the medicine remains at any moment. And when we take the derivative, it shows how fast the drug level decreases. In other words, it measures how quickly the body is clearing the medicine.
Okay, I get it now. Calculus isn't just about solving equation. It's about understanding how things change.
Exactly. It's everywhere. We just never realize. Do you want to eat lunch before our class?
Yes. Go.
Let's go.